So dear students, welcome to the lecture series of Design of Steel Structure. In today's lecture, we will be studying first the modes of failure of bolted connection. A bolted connection may fail by the three types of failure. First one is shearing failure, second one is bearing failure, third one is the tearing failure. Now, the shearing failure may take place in the two planes. Either it may be a single plane failure, or it may fails in the two plane. So by the definition, the maximum factor shear force in a bolt may exceed the nominal shear capacity of the bolt. The bolt may fail in a single or a double shear. If you observe the diagram number 1, here it is a diagram of a single shear. The force is by double cover single bolt connection. The second diagram gives us idea regarding the two plane shear, double shear failure of the bolted connection. Then the next comes the bearing failure of the plate or a bolt. When the member is subject to the shear force, slips takes place and the bolts come in the contact with the plate. In diagram number 3, you may observe that whenever the force exceeds, that time slip takes place and there will be a formation of a groove around the edges. Sometimes the plate is also been torn up to some part, and hence the last failure of the bolt is tearing failure. It occurs when the bolts are stronger than the plate and bolt fails in a stressed area when applied tension is the higher. If you observe the last diagram, here the total plate is torn out from the bolt connection. It occurs only whenever the bolts are stronger than the plate. So these are the three types of failures of the bolt. Now we will study bearing type of a bolted connection. It is assumed that the load to be transferred is larger than the frictional resistance caused by the tightening the bolts. Consequently, the member slips a little over each other, placing the bolt in a shearing and bearing. The number of bolts required is equals to the load divided by the strength of one bolt. Generally, minimum 2 or 3 bolts are provided even if one bolt is required. The strength of a bolt multiplied with the number of bolts in a joint gives the strength of a joint on the basis of the bolts. However, the failure of a joint can be in a bolt or in a plate, but as high strength plates are used, it is assumed that bolt will fail first than the plate, and hence we are designing the bolt for shearing and bearing strength and not for the tearing strength, because the tearing the plate, the force required is very much larger and it occurs very seldomly. That's why a bolt is designed for the shearing and bearing. We are calculating the number of bolts by dividing the total by dividing number of bolt by is equals to dividing the strength of a one bolt. Here the minimum strength of bolt in a shearing or a bearing is considered, and the total load is divided by the minimum strength of the shearing and bearing. Then we will learn how to calculate the strength in the shearing. That is, shear strength of the bolt. It is calculated from clause number 10.3.3, page number 75 of IS 800 2007. The resistance of a bolt to the shear is called as the nominal capacity of the bolt in a shear and denoted by VNSB. It depends upon the ultimate tensile strength of a bolt denoted by FUB. U resembles ultimate tensile strength and B resembles the bolt, and the number of shear plane is given by N. Then the nominal shank area ASB. S means shank area of the bolt. It is calculated by the formula pi by 4 into d square. D is nothing but the diameter of the bolt, and the shear area of the bolt at the threaded portion it's calculated by ANB, which is equals to 0.78 into pi by 4 into d square in each shear plane. Here the 0.78 occurs because 22% of the area is worn out because of the threads, and hence we are multiplying by 0.78, that is 78% to the shank area, or that is the shank portion area of the bolt. And the nominal shear capacity of a bolt is calculated by the formula VNSB is equals to FU into bracket NN into ANB plus NS into ASB upon root 3. The design shear strength of a bolt VDSB is equals to VNSB upon gamma MB, and therefore VDSB is equals to FU into AN plus NN into ANB into NN plus NS into ASH, bracket complete, divided by root 3 gamma MB, where NN is nothing but the number of shear planes in the threaded area, and NS is number of shear planes without the threaded area, that is the shear planes in the shank portion or the plane area of the bolt. Now, how to decide the value for NN and NS? This must be the question in the mind of every student. Dear students, whenever there will be a single shear failure, that time we may assume that the failure may occur in the threaded portion or the failure may occur in the shank portion, and hence the other remaining portion, that is, if the shear failure occurs in the threaded portion, that time in the case of single shear we assume that NS is equals to 0, that is the shear in the shank portion is 0, and vice versa. Then in the case of double shear failure, that time we have 4 cases. First one is if NN is the shear failure may occur in the threaded portion, and also it may occur in the shank portion. That time we have to assume that NN is equals to 1 and NS is equals to 1. Second case, we assume that both the shear planes occurs in the threaded portion. That time NN is equals to 2 and NS is equals to 0. Third case is that both the shear plane failure may occur in the shank portion. That time we assume that ns is equals to 2 and nn is equals to 0. So these are the four cases for the shear plane calculation, that is nn and ns. Now we will study the reduction factor. If the length of a joint, that is the distance from the first row up to the last row of the bolt, exceed 15 times the diameter of the bolt, then the reduction factor BLJ is multiplied. The formula for BLJ is in front of us. Then the large grip length, that is the depth here, this depth, vertical depth. LG, large grip length, is denoted by the L suffix G, exceeds 5 times the diameter of the bolt, then the shear capacity shall be reduced to BLG, and the formula for BLG is as in front of us. Then the third terminology is packing plate. In excess of 6 mm are used, the shear capacity should be reduced to beta pk, and the formula is in front of us. This is the yellow plate in front of us, is nothing but the packing plate. This plate is utilized to make the surface T1 and T2 a uniform one. Second one is the bearing strength of the bolt. Clause number 10.3.4, page number 75 of IS 800/2007 deals with the calculation of the bearing strength of a bolt. The nominal bearing strength of a bolt is denoted by VNPB and calculated by the formula 2.5 kb into D into T into Fu. Here Fu is nothing but the ultimate strength of the plate. Now here kb, the first coefficient kb, comes into the existence. The kb is calculated by E upon 3 times the D naught, that is D naught is the diameter of the hole, or P upon 3 times D naught minus 2.5, or Fu upon Fub upon Fu, or 1, whichever is smaller. Now in this formula we have small e, small p, Fub, Fu, D naught. Let me again highlight that D naught is nothing but the diameter of the hole, D is diameter of the bolt, E and P are the edge and pitch distances, T is nothing but the thickness of the connected plate, Fub is ultimate tensile stress of a bolt, and Fu is nothing but the ultimate tensile stress of a plate, respectively. The design bearing strength of a bolt VDPB is equals to F2.5 kb into D into T into Fu divided by gamma mb. Now here one thing one must keep into mind, that kb is minimum of all the 4 terminologies, or it is assumed as 1. Hence I can also state that value of kb cannot exceed 1. Then the third strength is tensile strength of the bolt. It is calculated by the formula from clause number 10.3.5, page number 76 of IS 800/2007. The nominal tensile strength of a bolt TNB is equals to 0.9 Fub into An should be less than FYB into ASB into gamma MB upon gamma M0. The design tensile strength TDB is equals to TNB upon gamma MB, where gamma MB and gamma M0 are nothing but the partial factor of safety. So dear students, in today's lecture, we have learned modes of failure of bolted connection and how to calculate the shearing, bearing and tensile strength of a bolt. So in next lecture, we will be solving numericals on it. So keep watching and subscribe the channel. Thank you.